discuss about isomers. Okay, first let us understand the meaning of the word isomers. Okay, iso means equal or same, and mers means parts. So isomers are nothing but compounds which have same. So now we are going to discuss about structural isomers. So you have to understand that compounds which have same molecular formula, also known as chemical formula, but different structural formula. That means the arrangement is different. So I hope this is clear. Now we have studied about two types of hydrocarbons. One is the alkanes, the other one is the alkene. Now we know the general formula for alkane, that is CnH2n plus 2, and that of alkene is CnH2n. Now just let us write the names of alkanes and alkenes. Now the first alkane is CH4. Okay. Now what was the name of the first alkane? That was methane. The name of the second alkane, that is C2H6, is ethane. C3H8 is propane. C4H10 is butane, and C5H12 is pentane, and so on and so forth. So if you observe, let us try to place it here. Okay, let us try to put it in the formula. C is 1, then H 2 into 1 plus 2. So that will make C1. H 2 ones are 2 plus 2, that is CH4. So it basically fits into the formula. Now what about alkene? So because alkenes have usually double bonds, that means I told you they are unsaturated hydrocarbons. So they will have C2H4, the first one, that is ethene. Then C3H6 is propene. I told you the suffix for alkane is ene. So this will be propene. Now C4H8 will be butene, and C5H10 will be pentane. These you have to remember, or you have to remember the prefix and the suffix. We know meth will be 1 carbon, eth will be 2 carbon, pro will be 3 carbon, but will be 4 carbon, pent will be 5 carbon, hex will be 6, hept will be 7, oct will be 8, non will be 9, and dec will be 10. You have to remember that, and you have to remember the general formula. Okay. Now you remember what did I tell you? That isomers, structural isomers, are compounds which have same molecular formula but different structural formula. Now let us see the first compound, CH4. Can I arrange it any differently? No. So it will have only one isomer because it can be arranged only in this manner. Second one, that is ethane, C2H8. like this, CH3, CH3. Isn't it the same thing? So therefore again ethane will also have one isomer. Third one, that is propane, C3H8. Now CH3, CH2, CH3. This is propane. If I arrange it like this, still it is propane because I will be counting 1, 2 and 3 carbons. So again propane will also have one isomer. Now the isomerism starts from butane. Butane is C4H10. Now how can I arrange butane? 1, 2, 3 and 4 carbons. 2, 2 and 3. Can we tally the number of hydrogens? This is 3 and 3, 6 and 2, 8 and 2, 10. So this is butane. This is a straight chain butane. Now, can I shift this chain somewhere? Okay. Let us shift it down here. CH3, CH2, CH2 and CH3. This is again similar only. There is no difference because I will be counting the carbons like this. But now instead of putting it on the first carbon, if I put this methyl group on the second carbon, then it becomes a different compound. Now it has 3 carbons on the main chain and a methyl group at the bottom. So a butane will have 2 isomers. One is your normal butane, which is also known as the N-butane, and the second one is, now how do we name it? Which group is this? This is the methyl group. This is the methyl group. And at which position is it? First, second and third. Which position? Second position. So it will be 2 methyl. And now the main chain has how many carbons? 1, 2 and 3. And we know any compound which has 3 carbons is called as propane. So the isomers for butane are 2. One is your N-butane or the straight chain butane, and the second one is 2-methyl propane. Now let us see the next compound. H12. So now this is pentane. Now the first isomer for pentane will be the straight chain. 2, 3, 4 and 5. Now, if I put this methyl group here, again it will be the same thing because I will be counting the carbons like that. Now, let us place the methyl group on the second carbon and see what is the isomer formed. One, 2, 3, 4 and 5. Now let us tally the number of hydrogens. 3 plus 3, 6 plus 3, 9, 10, 11, 12. Now let us again name it. If you remember, I had told before that while naming we always start from the end where the numbering will be the smallest. Now I will start the numbering from here. 1, 2, 3 and 4. Now if you see, methyl group is in which position? The second position. The methyl group is in the second position. So it will be called 2-methyl 1, 2, 3 and 4. We call 2-methyl butane. Okay. Now, what if I take this methyl group and put it here? Again, it will become 2-methyl butane because I will start counting from here. What did I tell you? It has to start from to get the lowest number. So again, it will become 2-methyl butane. So what else can I do? I can move this methyl group again and put it on the second carbon. So it will form a different compound. Okay, let's see. CH3 here, CH3 here, CH3 here, and CH3 here. Now, let us tally first the number of hydrogens. 1, 2, 3 and 3 fourths are 12. It is tallying. And number of carbons 1, 2, 3, 4 and 5. Now let us name it. Again, what did I tell you? If there are 2 methyl groups, then we call it as di. And the methyl group is at which carbon? 1, 2 and 3. So it's at the second carbon. So you will, because there are 2 methyl groups, so you will write 2 dimethyl. And let us count the number of carbons 1, 2 and 3. So if it's a 3 carbon compound, it's called as a propane. It's called as a propane. So how many compounds can you form, or how many isomers can you form? One is the straight chain pentane, second is the 2-methyl butane, and the next one is 2,2-dimethyl propane. So you can form 3 isomers from pentane. Okay. Now the next compound, hexane. C6H14. Okay. Now this is a hexane. They will not ask you more than hexane or heptane, because from hexane at least 5 isomers are formed. From heptane 9 isomers are formed. From octane 18 isomers are formed. They will not ask you more than hexane. So at least till hexane you should know. Now let us form the first isomer will be the straight chain carbon. Okay, that is the normal hexane. Now next isomer, this will be the hexane. Next isomer, what do you have to do? I told you, if you move it to the first carbon, again it will be hexane only. So now you will try to move it to the second carbon. 2, 3, 1, 2, 3, 4, 5, and I move it to the second carbon. And here. You just have to make sure that you are completing the valency of the carbon. Here 1, 2, 3. So there's 1 H. Okay. Now what will it be named? Again positioning. 1, 2, 3, 4 and 5. So the methyl group is in the second position. 2 methyl. 1, 2, 3, 4 and 5. That means pentane. Next, I can move this methyl group here as well. So it will be, if I move this here, it will make the next compound, that is 3-methyl pentane. Okay. Now, next, you got 2-methyl pentane, 3-methyl pentane. Now let's try. So let us plan it like that. 1, 2, 3, and if If I move this here and this here. So now 1, 2, 3, 4, 5. This is 3 and this is 3, 6. Correct? Now 3 carbon valency is fixed here, 3 carbon valency is done here. That means 6 hydrogens are already done. Then this 3 will make it 9 and this 3 will make it 12. Now these 2 carbons still have valency for 1 hydrogen. So here is 1 and here is 1. So this compound is 2,3 dimethyl 1, 2, 3 and 4 butane. So now how many isomers we have made? 1, 2, 3 and 4. There is a possibility for one more isomer. Now the last isomer, that is 2,2-dimethyl butane. If you observe, there are 1, 2, 3, 4, 5 and 6 carbons, and let us tally the hydrogen. 3 and 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now what we did is we took one more methyl group and just placed it on the second carbon. If I do the same thing this side, you will think it will form a new isomer, but no.